Good afternoon, everybody. Thank you for joining us today. My name is Sean Maurer. I'm joined today by my colleague Ryan Siegel. We'll be discussing key plan review items for the 2018 IECC. Just a couple housekeeping notes before we get started. We are recording this session. The slides and the recording will be available on our website probably within a week or so after the presentation concludes. If you have a question, please enter it in the Q&A window. If you hover at the top or bottom of your screen, you should see a Q&A box there. As you have questions during the presentation, please enter them there and we will answer them as we have time. If you do enter a question into the chat window, we will try to answer those, but those do sometimes get lost. So please, if you do have a question and want an answer, put it in the Q&A window. So to get started, today's session, we are offering continuing education credits for IECC and AIA. After the presentation concludes, we will be emailing out certificates. They will probably take about a week or so to get those out to you. Once you've received that certificate, if you want AIA credits, please email back to us with your AIA member number, and we will make sure to get those credits turned in for you. So what we're going to cover today as far as our learning objectives, we're going to try to understand the Energy Code Plan Review practices for residential buildings. We're going to be learning best practices for how to document in your plan drawings the code compliance requirements. And we're going to identify residential Energy Code Plan Review requirements detailed in the 2018 IECC. The Smart Energy Design Assistance Center is an applied research program at the University of Illinois. Our mission is to reduce the energy footprint of Illinois and beyond through educational seminars, energy assessments, and programs such as this. Our Energy Code training program is funded in part by the Illinois Environmental Protection Agency State Energy Office, so we like to credit them there. As part of our Energy Code training program, we also provide technical support. If you have questions about the Energy Code, need clarification, you can contact us at energycode@sedac.org, or you can call our hotline listed there on screen. We do prefer that you send us an email. It gives us time to confer among our staff and get you the best answer possible, but we can also answer those phone calls. We also have a number of online resources at sedac.org/energycode. We record all our workshops and webinars and post them to our website. We also have on-demand training modules available, and this is what that page looks like as far as finding those resources. We also have links to access the Energy Code, including online viewing access to the 2018 IECC. We do like to note that it does have a robust search function, so it's very useful. We also have links on our web page to the Illinois amendments and the Chicago Energy Conservation Code. There is also available at the IECC website, the Chicago Energy Code is available there now as well. Some of our upcoming workshops are listed here. Today we are covering residential plan review, and we'll have a follow-up webinar on February 9th. Residential site inspections we will be covering in October and March, and then we'll get into commercial plan reviews and site inspections in November, December, and we're going to be having code panel discussions where we'll have Energy Code professionals online with us to answer your questions and go over this process, trying to improve compliance with the Energy Code throughout the state of Illinois. And you can find a registration link there at our webpage for those webinars. So the first question we'd like to answer is, when does the Energy Code apply? From the 2015 International Residential Code, Chapter 1, Section 105, lists work that is exempt from a permit If you do not need to pull a permit, then the energy code is not triggered. Work that is exempt from obtaining a permit is listed there. Local codes may modify this list slightly, but in general, minor work inside a building, such as finish changes, countertops, cabinets, things like that, don't require a permit. Above ground pools or pools that are less than 24 inches deep. Electrical work that is minor, cord and plug temporary things, minor repairs, replacement of lamps. So I won't go through the full list. You can find it there. Also is listed in the International Residential Code. But again, if you don't need to pull a permit for your work, then the requirements of the 2018 IECC are not triggered. So how do you know if you've got a residential building or a commercial building? A residential building in the state of Illinois and in the IECC is defined as a detached one-family or two-family dwelling or any building that is 3 stories or less above grade. In the city of Chicago, that is modified to 4 stories or less above grade. That contains multiple dwelling units in which the occupants reside on a primarily permanent basis. So examples of this: townhouses, row houses, apartments. This would not include places like hotels, motels, where residents are there on a temporary basis. So now that you know you're in a residential building, what is required to be documented for that building in your plan drawings and construction documents for the plan review process? You need to be able to document your insulation materials and their R values. You need to document the fenestration U factors and solar heat gain coefficients. If you're using an area weighting average of those U factors and solar heat gain coefficients, you need to list that in the plan documents as well. Any mechanical system design criteria, sizing of the equipment, type of system needs to be listed. Mechanical and service water heating systems and equipment types, sizes and efficiencies. Equipment and system controls, so your thermostats and such. Duct sealing and duct pipe installation and location, and air sealing details. We'll step through these quickly. How would you reference those things in a way that's quick and easy for your code official to look at without having to hunt through the entire construction spec manual or the drawings? It's best to have a single source of data either on the prints or in a specified location in the specifications manual. That way you avoid having any missing data if you're tracking it all in one place. You also avoid having conflicting data potentially. And it provides a quick reference for the code official. They can look at this summary page wherever it's located and note in that summary where to find additional information. And we see this in a lot of drawings or spec manuals already, but we like to call this out as best practice to continue forward. Another thing that we're starting to see in some plan drawings, it's not as frequent yet, mostly because in many jurisdictions this kind of code summary is included in the application form. But if you can include on your drawings in that summary table what your compliance path is and some of your basic compliance requirements, that will go a long way towards helping your code official more quickly review your drawings and specifications to ensure that you're in compliance. While this is not required per the energy code, it is very, very helpful for that review process. This is an example from the Chicago's building department that we really like to call out as a good example of a way to document your compliance path. If you can document this in your application form with the building department or in your plan drawings or specification manual, this just helps your code official know what materials should they be looking for compliance. If you're going to be following the prescriptive path, they know to be looking for summary tables in your drawings or specification documents. If you're doing a res check, they know to be looking for those res check reports. And if you're doing some kind of energy rating index or simulated performance method, they know to be looking for model output reports for that documentation. So before we hand it over to Ryan to get into the plan review of the envelope, we do have a poll question that we will launch. The first question is choose which of those buildings is the residential building. And our second question, which of the following does the energy code require on your construction documents? It is multiple choice answer there. So if you all could fill that in, we'll give you a couple of minutes. We did have a question come in about if we know when Illinois will adopt the 2021 IECC. Ryan, I believe you answered that in the chat. Would you like to touch on that for everyone else?
Sure. The publication of the 2021 IECC is slated for next month of October of 2020. Illinois takes approximately 18 months, so that would place enforcement of the 2021 IECC somewhere around March of 2022. So approximately 19 months from now is when we'll anticipate that.
Okay. Still getting a few more votes in. Okay, looks like everyone who's going to answer has got their answers in. So the first question, which one of those is the residential building? Looks like everyone got it correct. There was the one answer, 5-story multifamily building. Must be 4 stories or less in Chicago, 3 stories or less in the rest of the state to be a residential building. So this would be a commercial building with some of the residential applications with it. But that is a commercial building if it's 5 stories. Nobody fell for the 3-story hotel. Good. No one fell for the factory. So good answers there. And then which of the following does the energy code require on the construction documents? Design team names, title sheet, fenestration U factors, mechanical system design criteria, air sealing details. You should have checked almost all of those. Fenestration, mechanical, air sealing, all need to be on there. Title sheet and design team names do not need to be on the construction documents, but they are generally part of them. So looks like everyone did a fairly decent job in marking those. I will now hand it over to Ryan to continue with our plan review of the envelope.
Well, thank you, Sean. It's something that was kind of touched on as far as the introduction is one of the objectives that's very helpful is to help go through and identify where information is located. So the quicker and easier it is for a plan reviewer to get to the information they're needing to look at, the smoother that review is going to go, and the quicker permits can be issued. So it's very helpful to make things as easy as possible for plan reviewers. It also can provide a good way for the design team can double check if they did. You may have noticed in one of the earlier tables, as far as some of the items are found both on the plans and in the design documents. So being able to easily double check and make sure that there's not a conflict there. So with that, getting into the envelope, something here is this is an illustration as far as what the schedule might look like for an envelope. Here we're dealing with some ceilings and wood framed walls and basements, calling out what type of insulation we're using, what the material is, and the R value that we are planning to use as part of the construction. Something else that we have shown here, even if it's not necessarily required, is this what the IECC requirements are. So that makes it real easy for someone to check. For example, we've got in our wood framed wall, we're using a R13 cavity insulation with an R5 continuous, and we can easily cross-reference that to the IECC using R13 plus 5. So again, anything we can do to make these comparisons quick and easy, the easier things are. Fenestration tends to get a little bit more involved. Some of this is because in order for area weighted averages needing to provide sizes, solar heat gains, U factors, visible transmittance, and air leakage. So there's a fair bit of involvement as far as details that need to be provided, particularly if you're using the area weighted U factor and solar heat gain compliance methods. And here again, you'll notice that we've included what the 2018 requirements are. Now, we do call out that to some of these tables, there are some Illinois amendments, particularly for basement fenestration and also in the the basement walls and the fenestration tables. Both have some Illinois amendments to them. So that's something to be aware of at this time. So here is an example of doing the actual calculation for the U factor and solar heat gain coefficient to show what the weighted average is across the various things. As noted earlier, this is required to provide this calculation for as part of the documentation for compliance. So as far as the if you're using a UA trade-off, which may include the res check, this is still a prescriptive path, but allowing trading between different components. In this example here, you can see that our maximum UA that we are allowed for this particular building is 335, and the design has a UA value of 628. So this is definitely not code compliant. If we go down and look at the table to determine, okay, where is our UA getting used up, a lot of it is the basement walls, and then some windows and walls. So those are likely to be the three things that we're going to be looking to address as we improve this design. Is we're gonna go through and look at those three areas, particularly that basement wall that's really struggling with the UA. As far as our air barrier construction details, we need to make sure that we're covering what the sealing methods are between any dissimilar materials and make sure that our sealing is allowing for expansion and contraction. You know, things are going to move, and so making sure that we are able to maintain that cohesive nature over time as the building ages. And making sure that as we're going through in the construction documents that we are providing adequate detailing and perhaps not just relying on whatever the manufacturer says to install it, particularly focusing on where dissimilar materials come together. We also like to point out this table, which we show a piece of here, this table R402.4.1.1. This table is very useful as far as it's not so much a checklist, but we have seen many people use it as such because typically if you run into a problem with mold or indoor air quality, those issues, generally the problem can be found with something was not followed in this table. So we're going through, this is one such method of detailing. Here we're calling out what the air barrier is in red and making sure that we're able to draw a continuous line along the entire air barrier. So from start to finish, we should be able to draw our line without having to pick up our pencil off the page. And by doing this, this also helps you identify where all of these dissimilar materials may be occurring, that you really want to focus on these details. And here calling out that, we have continuous bead of sealant. Construction documents likely would specify, is that an acoustical caulking? Is that just a regular caulk? And so making sure that we're covering all of those details as we go. So a question here as far as that air sealing, where the wall meets the foundation, and making sure that this joint is also sealed. Again, air sealing, we need to make sure that the air barrier is continuous. So you need to be able to draw all the way around the house for the entire thing. So again, we don't want to forget any of these joints. Here it's noting where we may have a treated product where it comes in contact with the concrete. Again, we have dissimilar materials, so we do want to make sure we treat that. So, as far as here, you may also notice in the attic, making sure that we have air sealed to improve that performance of that insulation. This is a commonly missed detail, is making sure that we actually provide that ventilation air that's going to go past through the soffit, up along the roof, and out through the attic. So when you have a vented attic space, to make sure that you either use an air barrier or an insulation that is not able to be penetrated by air. So here they're calling out rigid insulation to provide that air barrier from the bat insulation. So here's another one looking at some various walls, and here's even a soffit inside of a home, and here wanting to push that air barrier as far and not have it come into the space. It's not uncommon where we'll see, particularly in older homes, kitchen soffits where they didn't seal behind the soffit. And so that having that airspace go into the room is not ideal. You want to make sure your air barrier and insulation and thermal barrier are in intimate contact with one another. So when we're dealing with fenestration, some of this shows the alignment and the importance of alignment. In the figure on the left there, you can see where the window is kind of pushed towards the outside of that wall assembly, which allows for, as demonstrated by the red arrow, a lot of thermal energy being lost because of that misalignment of the thermal envelope. The picture on the right, you can see a substantial improvement by aligning that thermal envelope all the way through the fenestration and into the wall. So aligning those can be dramatic, can lead to a dramatic improvement in designs. Something else that we like to talk about is the 4 different types of barriers. We need to make sure that we have a bulk water barrier, an air barrier, a thermal barrier, and then a vapor barrier. And so making sure that as you're going through your design, making sure that you're identifying those. And you'll notice throughout this presentation, we're using red as our air barrier. So making sure that we're identifying that. So that can also be helpful if you go through and identify all 4 barriers on your design, as far as making sure that you do get them continuous, or how you're going to treat them if they are not continuous. So, another common area is slab edge insulation. This is one that has a few different options in the code. we have come across a few instances where there are difficulties with vehicle traffic, particularly with garage door areas. And so there now are new products coming to market, which are structural thermal brakes to provide some of that thermal brake. The all the way on the right is one where it's connecting two concrete slabs, one being an interior slab and the outside one being an exterior slab, commonly seen for like high-rise apartment buildings where you'll have a patio, a concrete patio coming out. And so making sure that we want to make sure that that thermal breaks so we're not just pulling all the heat right out through the slab. So there are continuing to be new products coming to market all the time for this. Also noting as far as for the requirements, the R10 for the slab edge for most slabs, along with if you have a heated slab on grade, either hydronic with radiant slab or electric, making sure that you have that plus R5 under the whole slab. Again, the importance being we have to have that thermal break between the slab and the ground. So with that, I believe we have another poll here. So I'll have Sean launch that here. Noting, is the area weighted average U factor and solar heat gain calculations required for the prescriptive path?
So we did have a question about whether the slides will be available after the seminar. Yes, they will be available. They'll be posted on our website along with the recording of the session.
We also have a question as far as venting of parapets for vapor and thermal heat to escape. Again, want to make sure that when vapor gets in, because we understand that even a building that may be constructed perfectly on the day it's constructed will degrade over time. So being aware as far as when vapor occurs or when vapor enters a system, we need to make sure that there is a way for it to get out, whether that is towards the inside of the building or the exterior. So making sure that you are cognizant of when you get vapor inside an assembly, does it have a way to get out? And making sure that you don't have two vapor impermeable faces where if water gets trapped in there, it's going to just degrade the whole system. So you can have a vapor barrier and a vapor retarder in a wall, but you don't want to have two vapor barriers. So as far as heat, I don't believe we typically see that we don't typically see that heat buildup in the parapet is as much of a concern. Typically, it's going to be more vapor and water infiltration that's a bigger issue.
As far as venting that parapet at the top, usually the parapet is tied into the wall assembly. If you've got a masonry wall or something, you've got the weep holes and venting at the bottom of the wall. Or if you're at different floors and you've got those weep holes at each floor level. Usually that ties that parapet in where it can ventilate that way as well. So you don't necessarily have to have a vent out the top. I have seen some improved parapet wall detailing where that insulation does not wrap up and over the parapet. It actually cuts underneath the parapet, and that avoids the potential of having a cold spot and condensation inside that parapet raised section. And I'll see if we can find that detailing, and maybe we'll add that to a future presentation as an improved compliance path.
Looks like most people got this, that yes, the weighted average calculations are required for the prescriptive path. So about 2/3 got it, and Uh, some of the people that said, I don't know, that's perfectly understandable. But yeah, so it is required, and it's okay if you don't know an answer at a given time. But with that, I'll turn it over to Sean for discussions on the mechanical, plumbing, and electrical.
Hey, so first we're going to touch on the mechanical plan review section. Um, in the mechanical plan review, you need to document the type of heating system, type of cooling system, um, and for your domestic water heating system, you need to document the capacities for each of those. And those capacities should be tied to an ACA manual J load calculation for the building, and then a manual S calculation for the sizing of that equipment. Also needs to summarize the efficiency of those equipment. What we've done is usually we see these summary tables in the drawings, and we've added in an IECC compliance requirements column so that there's that quick and easy comparison here. Once again, trying to enforce that if you can make it quick and easy for your plan reviewer to find these details, that will only speed up that plan review process for you. Another thing we wanted to note here, the IECC requires HVAC equipment for residential buildings to meet federal minimum standards, and we've included a link to where to find those federal minimum standards. Getting into the manual J down at the bottom there, we'll get into a little more detail, but you should be documenting the design conditions for your facility, either home or residential building. So that a code official can check this against typical design standards and verify that your design meets those design criteria. Your drawing should also have a system control narrative. For a residential home, especially a single family, it's usually quite simple. There's a programmable thermostat on the wall. Often now we're seeing these learning thermostats installed, such as the Nest. But you do need to document, even if you have one of those learning thermostats, it's going to change schedules and set points over time. You do need to document the initial settings and conditions for that system. Part of this is to help future owners if they need to reset that system, or if the system loses settings for some reason. Helps them get it back to an initial starting point. And then for these learning thermostats, they can readjust as they are in use. Another thing that we don't really see a lot of in drawings is duct sealing and insulation details. What we commonly see happen here is that the installers rely on the HVAC contractors to know these details and install them according to those installation instructions for the ductwork. But as duct sealing is a requirement for the energy code, as well as duct testing for residential buildings, it would be helpful to include these kind of details, especially if you've got any kind of odd duct joints or anything like that, because we do see this as a common point of failure for compliance, is that a duct joint gets missed somewhere, isn't sealed up, or the insulation is installed incorrectly. So it might be a good idea to start including some kind of reference details in the drawings as well, where usually we see this as just a reliance on the installers to know these details as part of the installation instructions. Moving on to plumbing plan review. One common thing we see with plumbing installation is the installation of insulation on plumbing piping. Something that would be very useful to include in those details is mitering of those insulation joints to relieve stress on that insulation and make sure it's not compressed, which reduces its R value. And also where it's stretched on the outside bends of those joints, that's a place of increased wear and failure for that insulation. Also, the drawing should identify the locations and systems that require that insulation. So for mechanical systems and hot water piping, any plumbing line or mechanical refrigerant line that's going to exceed 105 degrees temperature or be less than 55 degrees Fahrenheit temperature is required to have insulation on it. Typically, lines adjacent to the hot water tank will also have insulation on them. As you get out into the distribution system, there's not as much insulation on those lines that connect to faucets. But there should definitely be insulation, especially right by that water heater where the water is going to be the hottest. For dedicated hot water recirculation systems, the entire piping system should be insulated except those brief connections from the circulation loop to a fixture. And then there are some other items called out in section R403.5.3 for required insulation. But again, we'd like to stress that it's a common point of failure that we see over time, maybe not for the initial plan review and site inspection of buildings, but mitering those joints on that insulation will greatly extend its life and ensure that it has proper R value throughout the piping insulation. Another thing we like to call out, if you have installed a circulation system or a demand recirculation system, both of those have a demand component for the hot water system. There needs to be some identification of hot water demand in the space. For a demand circulation system, usually there's a recirculation pump out at the farthest fixture from the water heater or tankless water heater, or a fixture that's going to have the most common usage. And that's going to cycle on and off to maintain temperature in that hot water line as there's a demand for hot water. And for circulation systems, usually there is a flow monitor on the cold line that feeds into the hot water tank. We have seen on some occasions where that's been installed in the wrong place, such as the hot water line leaving the tank, in which case when that pump kicks on, if the flow sensor is on that hot water line, there's never a command for that pump to turn off because it continues to sense flow. So being sure that your plans call out those locations and details, and that if you have these circulation systems installed for your building, that there is a control narrative that specifies how that demand control is implemented for those systems. And then finally, moving on to the electrical review. This is really easy for residential because it's mostly just focused on lighting efficacy. There is an Illinois amendment as far as what qualifies as high efficacy lighting. We've highlighted in the table here the lumens per watt column. That is the column that you need to verify against whether those lamps are high efficacy or not. We do like to call out that R4.1 calls out that 90% or more of fixtures shall have high efficacy lamps. So this is a fixture based requirement, not a lamp or bulb count based requirement. So if you have one fixture that has 5 bulbs in it, that counts as one fixture for that 90% compliance. We did call out in this table here, just as a helpful note, there are a couple of fixtures that do not meet that high efficacy requirement, but it is less than 90% of the installed fixtures. So this is still a compliant lighting installation for this facility. But a summary table such as this is very, very helpful for plan review to determine whether you've met the compliance for that lighting. Before we move on to software compliance plan review, we have yet another poll question for you. Is time-based hot water circulation control allowed for water circulation controls?
We also had another question come in as far as a question on the vapor barrier and where that's located on the interior side of the wall. Vapor barriers are not addressed in the energy code. That is actually addressed in the building code. So the location and permeance of the vapor barrier, you need to reference the building codes to identify where that is. We're just noting that it is good practice to make sure that you identify where your vapor control layers are. as part of your design.
Got a few more answers coming in on this poll. We'll let it go for a couple more seconds here. Okay, looks like everyone's got their answers in. So are time-based hot water circulation controls allowed to meet that demand control? The correct answer is no in this instance. Because it does not detect occupancy or flow demand for that hot water system, time-based controls are not allowed. Okay, I'll hand it back over to Ryan, who will cover software compliance for plan reviews.
Okay. So as far as software, ResCheck is probably one of the more common ones. ResCheck, we also note ResCheck and ComCheck. Department of Energy has been moving to their web-based version only. And so making sure that you are using the web-based version. One particular benefit of using the web-based version of the software is that the software is always current and up to date. So you don't have to wonder, when you submit, when they find some software fixes that they need to do, you don't end up submitting a compliance report based on an out-of-date piece of software. So one thing that is nice about them is, as part of the reporting process for ResCheck, it provides you a lot of these checklists and documentation things. And so not only will it aid in testing and verifying that your design is compliant, but that it even gives the plan reviewer and the inspector a place to go ahead and fill in what they find. So that's where one thing that is missing here that would be good for a better practice is if it listed as far as what the plans showed. So that is something that we are also working on at SEDAC, is developing some of these checklists and compliance tools. So for those of you who may be interested in being a beta tester for some of our checklists, go ahead and let us know that through email, again, energycode@sedac.org. But so specifying here's what the requirements are, and then verifying does that verify all the way through? Was it something where the plans, I as a designer said it should be an R20 wall, the plan reviewer looks at it and says, yes, that's an R20 wall, and the inspector gets out in the field and says, that's an R15 wall. That's not a match. So helpful for some of these compliance tools as you go through and some of these checklists. The biggest change that we've been seeing is old rules of thumb going away. And a lot of that is because with energy codes and as the design profession improves, we are seeing better and better buildings over time. You think about the differences in buildings between what we built in the 1920s and what we built in the 1960s. We put a little bit more insulation in the wall, and that's about it. Whereas you look at buildings that we build today versus those that we built, just 15 years ago, that's seen a dramatic change over time. So that's something that as we touch on some of these, as far as the energy code requiring you to do your manual J load calculation or an approved equivalent. And then once you have your load, then you can do your equipment selection based on manual S. Something else that is not required by the energy code, but is a very good practice is ACCA has a manual D for duct sizing. What this can allow you to do is if you go through and do the manual D for duct sizing, then you can be much more assured that the air that leaves your equipment reaches the rooms it's supposed to and then gets back to the equipment. So your airflow pattern is going to be much more likely to be correct, and you're not going to end up with the likelihood of as many customer callbacks for comfort issues and things like that, where you're having to go in and manually balance the system and okay, well now that works for the summer, now I got to change it for the winter. So actually going through and doing these load calcs and then sizing your equipment and ducts correctly is very critical. Something else that can be very beneficial on is it can help drive down our first costs. Because we are building better buildings over time, these load calcs, we're seeing fewer and fewer or smaller and smaller equipment over time. One such building that we looked at had gone through and first someone came out and looked at it and said, okay, well, X number of square feet. Okay, yeah, that's gonna take a 5-ton unit. Said, well, where's the load calc? Oh, well, it's so many square foot per ton. Another contractor had looked at it and said, okay, ran through, did the design, and came back and said, no, looks like for a building of this size and this design and this insulation, we're looking at somewhere 3.5, just over 3.5 tons. So we're going to need a 4-ton unit. So just by that, the unit was able to downsize 20%. Plus, we're going to be able to have higher comfort and much better humidity control. Doing these little steps is very important. One area that we commonly run across is manual J's being done with wrong outside conditions. Here at the bottom of the chart, we note that the range for the state of Illinois for the winter is -4 degrees up to 10 degrees, and for summer, 88 up to 93 degrees. So if you end up coming across any manual J's with winter temperatures below -4 or summer temperatures above 93, that is incorrect. This is not these temperatures are not the maximum or minimum that we're going to see in a year. What this is this is going to satisfy the requirements 99% of the year. So there will be something on the order of 87 hours approximately that the temperatures will be outside of these extremes. Now, typically those don't occur all in one day or over the period of just a few days. Typically it'll be, an hour or two over here and a few hours over there. But when we're designing, we're not going to likely be able to size equipment exactly to what the load is. When we do a load calculation, you're not going to find out that I need exactly 36,000 BTUs of cooling, and so I need exactly a 3-ton unit. It might be, okay, I need 34,000. Well, the closest I can get is 36,000. So just by selecting your equipment, you're going to end up with a little bit of buffer that's going to carry most systems through that. And if it is outside of that range, it may be for a few hours, in which case the system will catch up as the temperatures return to a little bit more normal. So as far as what a manual J may look like, this is one of the speed sheets that ACCA provides at no cost on their website. They do provide these speed sheets. They don't necessarily cover all scenarios, but they are a good general use that can be very useful. And here what we've circled is we've selected our location for this building for our weather, Champaign-Urbana area, which then populates our outdoor conditions, and then we're selecting our indoor conditions. These indoor conditions can be one way that we've seen these manual J's manipulated. If we see a heating temperature of 80 degrees and a cooling temperature of 65, that is going to dramatically impact what the load calc comes out as. These 70 and 75 are actually the parameters that are called out in the energy code as far as your heating and cooling set points. Now, if you do have a client that does like things a little bit cooler, a little bit warmer, that is something that you can look at perhaps adjusting, and even if you're not designing that for your submittal, you can go ahead and make some adjustments to that to demonstrate to your client that the system you've selected will still satisfy them for their preferred conditions. So as we go through that, something that I'd like to notice here is when I start to look at, okay, for my windows, as we can see here, the heating BTUs per square foot really doesn't change a whole lot based on the direction. So, it's somewhere 37 BTUs per hour per square foot for this particular location for a double pane window, and the single pane windows are 86. So this is really a difference as far as, is this single or double pane windows, is it low E glass, things like that. So for the heating side, it's more about, is it double or single pane windows? The direction is less important. Now on the cooling side, what we can see here is there's a much larger difference as far as what your cooling BTUs that you need are. North is going to have a much lower solar gain than either east and west or south windows here. So there again, on the cooling side, it's going to be more about the direction of the windows are facing, and then the heating, it's going to be more about the U values. So, so on the cooling side, you notice the single pane windows on the cooling side really do not have as much of an energy penalty as one might anticipate here in this. We can see this may depend based on do I have shading over some of these windows, like the lower ones that are showing a 65 BTUs per hour per square foot. That's probably a more heavily shaded window. The 86 is our single pane, and a 70 would be our double pane with perhaps less shading. So that can be taken into account. Something that was noted, had a plan reviewer going through these, was checking to see, do I have any holes? These being white cells, for those who are not familiar with the manual J speed sheets, white cells are automatically calculated. And so here we notice there's a couple of holes here. And what we determined was there was actually some cells that had not been filled in, sorry, that is incorrect. The white cells are what I'm filling in. The blue are calculations. So here I have a couple of blank cells where I had failed to fill in the heating and cooling square footage and cubic foot. And how that was identified was to the right, cooling BTUs per hour is blank. And that being a blue cell says this isn't automatically calculated, something is missing here. So that's something also to go through as you're checking through these manual J's is, did you make sure to fill in all the blanks? As far as ventilation types, this is something that ventilation is now required for residential new construction. The three types that we see is negative, positive, and balanced. These are found in order of most common to least common and least desirable to most desirable. When we are using a negative ventilation, we're just exhausting air out of the building continuously, which then we're relying on infiltration coming through my building envelope, which if I'm pulling air through my building envelope, I'm likely bringing with it dirt, pollen, and humidity. Humidity inside a wall is not good to have build up. So I'm pulling unconditioned air through that building envelope, which is not good. The second, which is a little less common, is positive ventilation. Typically, this is done either through an air handler or dedicated fan, which now I'm relying on exfiltration. So I've brought in extra air, conditioned it. Now I'm pushing conditioned air through that wall assembly. So I'm a little less likely to end up with potentially mold issues or other indoor air quality issues through that. However, if this is done through the air handler, you have to install a unit to operate that fan at least 25% of the time. So it has to run at least 1 hour out of every 4 during the day. So that can put more wear and tear on those fans if they're not designed for it. And then finally is balanced. So this can either be through an ERV or HRV, an energy recovery ventilator, or heat recovery ventilator, or you could just use 2 fans where I'm going to bring in a certain amount of air and I'm going to exhaust a certain amount of air just to keep it balanced. So balanced is definitely preferable because you're not relying on air to leak through that envelope that you've tried to make airtight. So here's some examples of duct sealing and at the boots, and making sure, and here again, making sure to note on the prints, all these different joints that we have to make sure we get sealed. Because again, if we end up with air leaking out of ductwork, it's less critical if it leaks into conditioned space. However, this is air that was supposed to arrive at a room, and so if it's leaking out of the ductwork, again, your manual D, if you did it and didn't account for any leakage, that's going to give you some issues later on. And so, and here again, here's another one for wall assembly for a dryer or vent hood. So again, here they're calling out, making sure that you seal all of these different penetrations, all the different points that you need to seal in going through that. So with that, I think we've got one last poll and a few other questions that have come in here. So
launch that poll. Question is, what air sealing details need to be included in construction documents? It is a multiple choice question, so pick all the ones that apply. While we're answering that poll, we did have a couple of questions come in. I wanted to touch specifically on, since we were just talking about ventilation in the residential, is makeup air required in a single family home, specifically in kitchens with exhaust hoods with high CFM exhaust? Yes, you do still have to have mechanical ventilation. The reason being, those kitchen hoods do not run on a consistent basis. They're based on, when's the person cooking and when do they remember to turn it on. Mechanical ventilation has to be a designed fixed rate of ventilation coming through that house to provide fresh air. So that does need to be a fan or system that's on a timer or running continuously in order to bring in that required ventilation rate.
And this question specifically was about high exhaust fans. As I recall, the threshold is 400 CFM. So if you have exhaust fans above 400 CFMs, then you need to have a makeup air unit. you cannot rely on just your regular ventilation unit to provide that makeup air. So you're going to have a booster if you have more than 400 CFMs for a exhaust hood.
Okay, our next question, if a basement is to be left unfinished, will it still require insulation on the exterior walls? This depends whether the basement is conditioned or not. If you insulate the floor above the basement, and that basement area is thermally isolated from the house, it's got a weather strip door down the basement stairs, the floor is insulated, then no, you do not need to insulate that basement wall. But if that basement is conditioned, if like your air handler is down there and you've got supply and return vents, then yes, even if it's unfinished, it will need to be insulated. Next question, R402.3.2 and R402.3.2 require U factor and solar heat gain to use area weighted average or merely permit it as an option other than using solar heat gain and U factor for each window. It is an optional method. You can either use the area weighted average or you can use a prescriptive value for each individual unit.
See a question here regarding manual J, D, and S. The code requires manual J and S, so you must do a load calc and a sizing calc. Manual D is optional. It's not even referenced in the code. It's just something that we like to bring up as a best practice that is readily available out there. So yes, for energy code, you have to do your manual J and S, and we would recommend doing a manual D.
Looks like most people have answered the poll questions. I'm going to end that and share the results. What air sealing details need to be included on construction documents? Building envelope is correct. Air duct sealing is also correct. Plumbing doesn't require air sealing unless it's penetrating through an assembly, in which case it should be documented in the building envelope plans. Insulation, again, that's part of the building envelope. So air sealing is not required to be documented there. It is documented as part of the building envelope. And lighting plans. If you've got can lighting that is penetrating through your thermal envelope, such as into an unconditioned attic, then yes, you would need to have air sealing details for that. So the correct answers for this is all of these, but the last three there are generally included as part of the building envelope or air duct details. We did have a question come in. Do we know what percent above below manual J calculated loads the manual S will determine for equipment types? I don't know the exact percentage, but I do know in most situations the manual S will size the equipment to the next largest size that meets the manual J load calculation. Okay, we did a question on our parapet diagram. It showed air and vapor barriers on top of the roof slab sheeting. It's showing that primarily in that instance, some of those barriers are made of the same material. So you can have an air and vapor barrier combined into one item. So like the roof slab is technically an air barrier, and also the membrane covering the roof is technically an air barrier as well, as long as it's sealed together. So while the diagram kind of showed that as a single line running through those, it's really the combination of those materials that the composite, that combined air and vapor barrier material.
And some of these are just design choices as far as where to locate them. The important thing is to make sure you, as part of your design, that you are identifying so you're aware as far as where those are, so that you don't end up accidentally trapping moisture where you don't want it. As far as ductwork in an unheated crawl space, is it required to be insulated? As I recall, ductwork in unconditioned spaces is required to be insulated, the level of which is based on the size of the ductwork. And as I recall, for residential, it is also based on the location. So a crawl space and an attic have two different levels of insulation, if I recall, in the code. So yes, if you have ductwork in unconditioned spaces, you do have to do that. Something else to be aware is if you have ductwork that leaves ductwork and or the air handler is not in conditioned space or leaves the conditioned space, then you are required to do duct testing. That is one of the other large changes coming up for the 2021 version of the code, is that all ductwork, regardless of if it's in the thermal inside the conditioned space or not, will have to be tested. And again, I think part of that goes back to that recognition of that air is designed to reach a certain space. And while we don't necessarily have an energy penalty from releasing it into the conditioned space at a different location, you are definitely going to you will likely cause a comfort issue. So.
As far as the duct insulation levels, if it's in an attic space, ductwork larger than 3 inches must have R8 insulation, R6 if it's less than 3 inches. If it's in any other part of the building that that is unconditioned, such as an uninsulated crawl space, that ductwork should be R6 for larger than 3 inches and R4.2 for less than 3 inches.
We also did have someone, actually that's very good to know. One of the people attending today's webinar has brought up that Manual D is actually required under the residential code, IRC Chapter 16. So even though the energy code does not require Manual D, the residential code would require that. As far as that may depend on which version of the residential code your jurisdiction may be on, but be aware that, so that would be Chapter 16 may make reference to the Manual D. So thank you so much. Appreciate it, Don.
Let's see here. Did get a question about City of Chicago insulation requirements for insulation on the underside of the roof deck. Have they modified their requirements for insulation to permit closed cell spray applied membranes or spray applied insulation? We'll have to look into that. I don't have these Chicago amendments available right in front of me, but we will get back to you with an email and answer that question for you.
Just want to remind everyone about the upcoming webinars. In addition to the series that we mentioned today, there's also one on the City of Chicago EV requirements that are going to be enforced as far as the new EV ready ordinance beginning November 1st. That presentation is, I believe, October 7th that we have.
8th, October 8th.
October 8th, sorry. Yes, October 8th, there will be a presentation on the Chicago EV Readies. That is also, I believe, another change coming to the 2021 IECC is the 2021 IECC will also be moving towards EV electrification ready. So if those of you who may want to be prepared in advance of the 2021 or have projects in the city of Chicago, look forward to seeing you on October 8th for that.
All right. Unless we have any more questions that come in, we would like to thank everyone for their attendance today. We hope this was an informative session for you, and we'll see you at our next workshop. Have a great afternoon.